Hello everyone. Today I'll be presenting on probability sampling in the context of AI-driven cybersecurity leadership in Homeland Security. This presentation focuses on quantitative research design, sampling strategies, and data collection, and how these concepts connect to my dissertation research. By the end of this talk, you will understand both the principles of probability sampling and its relevance to elite cybersecurity leadership studies. Let's begin with an overview of what we will cover. In this presentation, I will first explain the purpose of probability sampling and its importance in research design. I will discuss how sampling supports reliable data collection and differentiate quantitative approaches from qualitative approaches. Then we'll explore probability sampling principles, requirements, and a concrete example. Finally, I will connect these concepts to my dissertation on AI-driven cybersecurity leadership and summarize key takeaways. This structure ensures that both theory and practical applications are addressed. Let's talk about probability sampling principles. Probability sampling is a key method in quantitative research. The core principle is that every member of the population has a known, non-zero chance of selection. This requires a clearly defined population and an accurate sampling frame. Objective selection procedures minimize bias, and the approach supports inferential statistical analysis. Finally, probability sampling enhances generalizability, allowing researchers to confidentially apply results to the broader population. Now we talk about quantitative research design. Quantitative research design is structured and relies on numerical data to answer research questions. Its primary goal is to generalize findings to a large population, often through structured instruments like survey and experiments. Quantitative research focuses on measurable variables and uses systematic methods to minimize bias. For example, when studying cybersecurity leadership competencies, numerical ratings or survey response can quantify perceptions of leadership effectiveness. Proper design ensures reliability and validity in drawing conclusion. Here's a target population example. A practical example is a state cybercrime task force. These units maintain formal, accessible rosters, allowing researchers to apply simple random sampling. Each officer can be assigned a number, and a random generator selects participants, ensuring equal probability. This approach represents key subgroups and aligns with established criminal justice research standards. In contrast, Homeland Security leadership research rarely enjoys such uniform access, as leaders are dispersed across multiple agencies and private partnerships. All right, let's talk about sampling and data collection. Probability sampling directly informs data collection. Structured instruments such as surveys or questionnaires can be administered to the selected participants. This enables valid statistical comparisons and ensures that findings are generalizable. By using standardized tools, researchers strengthen credibility and can draw meaningful conclusions about population trends. In AI-driven cybersecurity research, these principles help identify competencies, behaviors, and decision-making patterns consistently. Let's talk about challenges in Homeland Security. This is true for any social science field as well. Applying probability sampling in Homeland Security research comes with challenges like for the other social science fields. Leaders operate across multiple sectors, including federal, private, and intelligence organizations. Many positions involve classified or restricted responsibilities, limiting access. Complete sampling frames often do not exist, making random selection impractical. These constraints necessitate adaptive approaches, including purposive or expert sampling strategies to ensure research. All right, let's talk about how to apply to my dissertation probability sampling. My dissertation focuses on identifying strategic and managerial competencies for AI-driven cybersecurity leadership. While probability sampling provides a conceptual framework, qualitative methods are necessary to capture the experiences of elite leaders. Expert interviews and document analysis allow me to explore complex competencies and intelligence challenges. By referencing probability sampling principles, I maintain methodological transparency and connect my study to broader research standards. This approach ensures depth and rigor while acknowledging practical limitations. Ooh, now we are here for summary and takeaways. In summary, probability sampling is foundational to quantitative research, providing clear principles for population definition, sampling frame construction, and equal selection probability. The example of cybercrime task force illustrates its practical application. While Homeland Security leadership research often requires qualitative approaches, understanding probability sampling strengthens methodological rigor. Quantitative principles inform data collection, even when qualitative methods are used. Ultimately, these insights guide credible research design and actionable findings for cybersecurity leadership development. Thank you, and I welcome any questions or discussion.